Hello and welcome to another video for the pre-calculus series hosted by Jeremy Lane. And in this video, we are going to introduce methods for determining if lines are parallel. So two lines are called parallel in two dimensions if they do not share a point. This is denoted as L1 and then two vertical lines between them, and then L2. Basically, this is saying that L1 is perpendicular, or I'm sorry, parallel to L2. The procedure to determine parallel lines is here. It's 4 steps. Step 1 is find the equation of one of the lines. This is usually done by using 2 points, the point slope formula, or it is a line is already provided for you. Normally, we try to have this line in slope intercept form. In this case, y equal m1x plus b1. And that is our first step. So our first step is to find the equation of the line if it's not already provided. And second step would be the slope of the second line must be the same as the slope of the first line. So if m2 is the slope of the second line, then m1 has to be equal to m2. And this is just part of the conditions. Having the same slope is not quite enough to guarantee a parallel line. And that comes in with step 3. In step 3, you want to find the y-intercept of the second line. And we'll go ahead and just call it B2. B2 cannot be equal to B1, otherwise the lines are identical. Remember, they already have the same slope. So parallel lines have the same slope and different y-intercepts when you're trying to find the equations of these parallel lines. And then, of course, step 4 would be to determine the form of the line desired, whether it's slope intercept or standard. If it is not already mentioned, usually that implies a slope intercept form. So for our first example, we'll go ahead and find the equation of the line parallel to the line formed by the points 1, 1 and negative 5, 4. And the line parallel has to contain the point 2, 2. So our first step is to find the equation of the line formed by the points 1, 1 and negative 5, 4. So we go ahead and find the slope, and the slope is negative 1/2. The y-intercept is calculated here as well. We find that to be 3/2. So the equation of our line is negative 1/2 x plus 3/2. Now, the slope of the parallel line has to have the same slope of the original line that we're trying to find it parallel to. So that slope is also negative 1/2. The y-intercept of the second line is found again by the formula, y coordinate minus slope times x coordinate. But remember to choose the x and y coordinates from the point that the parallel line has to go through. And in that case, that's going to be our 2, 2 point. So we plug it into the formula and we get 3. Now, 3 does not equal 3/2, so the lines are distinct because they have the same slope and different y-intercepts. And finally, we may write our slope-intercept form of y equal negative 1/2 x plus 3. So we have our 2 parallel lines. Second example, which appears often, is to find the equation of the line parallel to the line x equals 7, going through the point 1, 5. Well, x equals 7 is a vertical line. And vertical lines do not have a slope. So when we say, what's the slope of this x equals 7 line, we say the slope does not exist. But that does not mean that we can't proceed any further. It simply means that the slope of our parallel line must also not exist. Thus, a vertical line is what we're shooting for. So we want to go ahead and, under that pretense, go ahead and still continue to find the y-intercept. The line is vertical, so there's not going to be a y-intercept. So essentially what we're going to do in a case like this is we're going to go ahead and take the x coordinate of the point we need to go through, in this case 1, 5, and say that the equation of the line has to be x equal 1. X equal 1 and x equal 7 are in fact parallel, even though they don't quite fit all of the steps that are laid out in the procedure above. We can still go ahead and find the equation of a line parallel to a vertical line by following the same guidelines. They have to have the same slope. They have to have different y-intercepts if they're there. This is one case where there is no y-intercept, and therefore, and also there is no slope. So therefore, we have to go through the x coordinate of the point we're going through, and that will guarantee that we're parallel to another vertical line in this case. So x equal 1 is parallel to x equals 7. It does have the same slope, and because they don't have the same, because there is no y-intercept, we'll have to just say that these lines again are parallel. For our third and final example, in this case, we're actually given the equation of a line. Find the equation of the line parallel to y equal 4x minus 2 through the point -1, -3. So our first step is to go ahead and find the slope of the parallel line. We know that the slope of our original line is 4. That's the coefficient of x. So our parallel line has to have the same slope. The y-intercept of the line that we're given is -2. So whatever y-intercept we find, it has to be different than -2. So we're gonna use our formula. Here we have y2 minus m2x2. That's the y coordinate minus the slope of the line times the x coordinate. And remember, those things are all associated with the line that we're trying to build. So we have -3 for the y coordinate, minus 4, the slope, times -1, the x coordinate of the for the point we're trying to go through. We do the arithmetic and we get 1. Now, for the line that we're already provided, -2 was the y-intercept. For our new line, 1 will be the y-intercept. Those numbers are different, and so our lines are going to be distinct. And therefore, we can put them in the slope-intercept form, and we have y equal 4x plus 1. So the thing to remember about parallel lines when you're finding them is that you go ahead and find the equation of the line that you have enough information for. And then for the parallel line, it has to have the same slope, and it has to have a different y-intercept. And once you construct those and you put the new line in its proper form, whether it's standard or slope-intercept form, you will then find the equation of a line parallel to a line that's being provided. Thank you for your time and attention.